we're going to review area under the curve and average value. And like I said, we're just going to add the ideas of U substitution and our trig derivatives to these two ideas and just go back over it to make sure that we know what's going on. The first one we're going to look at is find the area of the region bounded by the graph of y equals x over x squared plus 1, the x-axis, and the line x equals 3. Now, you don't have to have the graph in order to do this problem, but let's take a quick glance at what this function does look like. So the red curve there is the x over x squared plus 1. It says we want area under the curve bounded by that curve, the x-axis, so we've got the x-axis right here, and the line x equals 3. So the x equals 3 tells us where our interval ends. It doesn't explicitly state it, but the assumption is since we're talking about the area between the curve and the x-axis, then our interval would start at 0 since this function does indeed go through the origin. So if we're finding area under the curve is the integral. Like I said, this interval starts at 0. It ends at 3 of our function, x squared plus 1, or x over x squared plus 1, integrated with respect to x. This is a U substitution problem. So our U is our denominator, x squared plus 1. So when we take the derivative of that expression, we get 2x. We don't have 2x in the problem, we have just x. So the 1/2, we need to move the 2 to the other side so that becomes 1/2 du, and we've got x dx. So this is covered by the 1/2 du. This is our u. And don't forget, since we're doing U substitution with a definite integral, let's go ahead and change our limits. Plug your limits into the expression for u. So plug in 0, we get 0 squared plus 1, so our lower limit is now 1. Our upper limit, plug in 3 squared plus 1, so our upper limit is 10. So when we substitute everything that we're supposed to substitute, we have a 1/2 in front, the integral from 1 to 10 of 1 over u du. Any questions about what I've done so far? The antiderivative of 1 over u is the natural log of u. Well, since I changed my limits, I'm just going to leave it in terms of u. I don't have to plug the x squared plus 1 back in there because I changed the limits. If you didn't change the limits, then yes, you need to put the x squared plus 1 back in there. Yes, but I show you this for the reason that sometimes they have problems where they'll say which of the following integrals is equivalent to the original one, and they're wanting you to recognize a U substitution and that the limits have been changed. So I go ahead and show you this. Yes, technically you can go ahead and plug in x squared plus 1 and leave it with 0 and 3. You end up with the same thing, right? You still end up with 1 and 10. It's just a different way of looking at it. Now, this is not calculator active or anything of that sort, so we are forced to leave it in this form. However, you should know that the natural log of 1 is equal to 0. So the area under this curve is 1/2 times the natural log of 10. Any log of 1 is equal to 0, because remember what log form says. The natural log of 1, that says that e to what power equals 1? Well, e to the 0th power equals 1. Any base that we've got. If it's log base 2 of 1, 2 to what power equals 1? 2 to the 0th power equals 1. So any log of 1 is automatically 0, and they do expect you to make that simplification there. Okay? All right, Another problem, find the average value of f of x is equal to tangent of x on the interval from 0 to pi over 4. Anytime you see the words average value, you should automatically be thinking 1 over b minus a times the integral from a to b of f of x dx. Automatic there. Okay, so in this case, our b minus a, pi over 4 minus 0, just leaves us with pi over 4. We'll flip that here in a minute. From a to b, so from 0 to pi over 4. Label it if you have to. Okay, this is still, your AP exam is paper pencil. I want you to write all over this test. Okay, they're not going to grade or judge anything that you have written down. So I'd rather you label everything as opposed to not. All right, so 1 over pi over 4 is equivalent to 4 over pi. The antiderivative of tangent is the negative, so I'm just going to stick that in front of the constant, natural log of the absolute value of the cosine of x. So we're evaluating that from 0 to pi over 4. There was no u substitution here, so we just leave the limits the way they are. If that had been something other than just tangent of x, if that had been tangent of x squared or tangent of 4x or something, then yes, we would have changed the limits. So plug in the upper limit, pi over 4, minus the lower limit, 0. I really don't need the absolute value at this moment because I know both those values are positive, but I just left it. The cosine of pi over 4 is the square root of 2 over 2, so that's the natural log of the square root of 2 over 2. And the cosine of 0 is 1. So minus the natural log of 1, which we just dealt with that. Natural log of 1 is 0. So our answer, as strange as it looks, is negative 4 over pi, natural log of the square root of 2 over 2. That's the average value of this function on the interval.